So I said we will start 2 minutes after the hour, and that's what we're gonna do. So hi again, I'm Daniel Siegl from Lieber. I'm your host today, and I'm very excited to show you a scenario with LemonTree and Codebot from Parallel Agile, where you can see how these tools play together very nicely. I have Matt Stevens from the UK, from Parallel Agile with me, and Doug Rosenberg, who apparently cannot switch on his video right now, but Doug is with us. Doug is very well known in the enterprise architect community, but we will hear more about that later. So the topic is obviously, when we are involved, it's somehow related to LemonTree, to fresh ideas for model versioning, and yeah. So Doug, Matt, it's your stage.
Okay, thank you, Daniel. So we'll just start with a short introduction to Parallel Agile. First of all, we have a book. It's called Parallel Agile. And the whole premise of Parallel Agile is to enable faster delivery of software applications by allowing large teams to collaborate together more seamlessly. And, you know, we're trying for the holy trifecta here, which is to get done faster with less bugs and less money. So modest set of goals for Parallel Agile, but that's what we've been trying to do. Go ahead for the next slide, Daniel. So the basic premise is that we're trying to apply parallel processing techniques to software engineering. And, you know, in most forms of engineering, if you want to go faster, you put larger teams on the problem. In software development, that's been sort of a big exception because the small team agile is really what dominates the industry in terms of how most companies attack software development. So with small team agile, you sort of have this ongoing sequence of 2-week sprints, you know, short sprints by small teams. And with Parallel Agile, we would like to be able to have larger teams collaborate. And we do this by essentially assigning a developer per use case. And we've been working with Barry Beam at USC, Professor Beam, and he's, of course, the author of the incremental commitment spiral model, or just spiral model for short. And the spiral model sort of takes things in 3 phases. You do a proof of concept, and then a minimum viable product, and then you get to release and optimization. Go ahead and hit the next slide. So I've been fortunate to have been working with Barry for a few years now. And the spiral model was really developed as an overall life cycle model for a large project, actually very large projects. And the twist that we've done with Parallel Agile is we've taken the spiral, we've sort of simplified it. So it goes into just sort of this 3-phase proof of concept, MVP, and optimize spiral. But we've put the spirals inside the use cases, which means that each of these use cases can evolve sort of asynchronously from the others. And you can actually have large teams of developers with a developer working on each use case. So we've had really interesting results with it. Go ahead, Daniel, hit the next one. So in order for this to work, what we found, we've been working on this at USC for, I don't know, 6 years now, I guess. And we found that in order for collaboration with large teams of developers to occur effectively, It really helps if everybody has a shared model of the problem domain, so in UML terms, a domain model, and that if we code generate an API, essentially an API for database access from a domain model, so now we're taking sort of the Eric Evans domain-driven design approach and combining it together. I don't know if anyone's old enough like me to remember Steve Miller, Executable UML. This is one of the early UML books that came out quite a long time, like 20 some years ago. But we've sort of taken domain-driven design and jammed it together with executable UML, and we built what's now called Codebot. And Codebot lets us have all these developers each working on separate use cases, but they're all collaborating through a shared REST API. So everything in your problem domain can be accessed by the API. Go ahead. Next slide. So we started with essentially Codebot developing an API for database access, but more recently we have been exploring user interface code generation. And so this allows us now to generate screens from wireframes. So EA wireframes get turned into, at the moment, React.js code. And then we can string those screens together using UI navigation state machines. So essentially what we're doing, and we'll show you an example here in a second, but essentially we're turning your UML model or SysML model into code, okay? And, you know, yeah, don't switch me before I give the punchline. The punchline is, you know, when your models become code, they need to be version controlled like code. Okay, so if you have a large team of developers and you add, you know, 3 new developers working on 3 new use cases, those models, you really need effective version management on those models. And that's where the synergy between LemonTree and the feature branching comes in with the one developer per use case parallel development. So now I think we can go to the demo.
Yes, thank you, Doug, for making the point. I think this is a very important lesson learned. If you want to do sustainable models, you have to derive stuff from your models to make sure they are really used and up to date. And if you do that, you need to version control your models. And now we will have Matt share his screen. And I will go on mute again.
Do that now. There you go.
Okay, so let me introduce the example. So a few years ago, I taught model-based systems engineering at university at USC, and I had my students design, I had a lot of aerospace type students in my class. And so I said, all right, you have 16 weeks and you're gonna design either one of 2 systems. One was a 2-way wristwatch TV, like from the old Dick Tracy comic strip, or you could do a mosquito killing laser that only killed mosquitoes and it left butterflies and houseflies and things alone. So when we started doing our user interface code generation and the state machine code generation with Codebot, I decided to resurrect this example. So what we're going to show you here is our mosquito killing laser system. So if we just look at these states briefly, you start out, we have an audio system where we're listening for the whine of a mosquito. We're going to localize that target to a specific area in space. We're going to light up our search sector with an infrared beam, and then we're going to scan for a target. We're going to track the target, fire our laser at the mosquito, and then assess the damage on here. So Matt's going to walk through these various states now. Yeah, you can close that one, Matt. So, and the way Codebot works is if you make a wireframe and the name of the wireframe is the same as the name of the state, it basically makes a screen and it will sequence those states according to the, or sequence the screens according to the state machine. So we're going to listen for mosquitoes. Go ahead and close that one, Matt.
Sure.
Yeah, we're just going to like,
yep.
Then we're going to localize the target. So we have a 3-dimensional array of microphones here. So we're going to localize the target to XYZ coordinates. Close that one. And then we're going to light up our search sector. And yeah, just close that one. And then we're going to scan for our mosquito. And you can see that we can take multiple exit paths out of this state. If we find the target, we do one thing. If we don't find the target, we go back somewhere else. Then we go into tracking. And once we're tracking the target, then we can fire the laser. And then we can assess the damage that we caused. And so what Matt's going to show you now, so it takes about 3 minutes to code generate this and produce a basically an online website. And so we're just going to skip the 3 minutes and Matt's going to click visit website here. This is our Codebot console. And you can see we've got 2 versions of this model, so we're going to get into the version control here in a minute. But if you click visit website, VSRADS, by the way, stands for Very Short Range Air Defense System, if you're curious about the acronym. So now this is a live website built in React.js, and Matt can step through the states here. So this is now running executable code. So target localized, search sector's lit up. And if we don't find it, we go back to listening again. So it's really implementing the full state machine. Go ahead, target found. We're tracking, and then we can fire the laser. And then go ahead, firing complete. And then we're going to check to see if our mosquito has been properly incinerated by our laser beam. If it's not killed, you can go back and track it again. I'm told by a friend of ours who does weapon system, this is called shoot, look, shoot is the paradigm for these. So, okay, target destroyed. And then it just goes back and listens again. So now we're going to add a new use case to this. So let's go back to EA.
Yeah. So what I've done for this is we've got 2 separate models. So we've got this one, and so the idea is that we've got two separate developers working on these. So the second developer has got a copy of the model, and in that they've added. I didn't have to show. We didn't show you the domain model previously, but we've added this class simulation run. Sorry to interrupt, Doug. And then
No, that's right.
Yeah,
that's fine.
Sure. Then back to here. So if you want to.
So now what we've got is we've got a new state that got added in here. Okay, and the new state is to set up a simulation. And you got a wireframe for that one?
Yeah. So, oops, not that. It's in the wireframes. So it has the same name, setup simulation as a state.
Yeah. So now what we've got is from this screen, we're actually going to populate that domain object in the database for the simulation.
Yeah. So there's a domain object being, so that this form is linked to this domain class simulation run. So that's how Codebot knows to generate this into something that actually writes to the database when this is submitted.
So if we code generate this one again, we can go back to the Codebot console and just switch to version 2 of the model, right? And then visit that website. Again, it takes about 3 minutes to do this, so we didn't want to inflict a 3-minute delay in the middle of the webinar. But you can create a new simulation run, call it, run number 10 or whatever.
Sim 10 version, maybe 4 mosquito targets.
Yep. And so
we've got some, there's a custom script that's running in there. So you can add your own custom JavaScript that gets injected into the generated page as well. So that's just showing alerts on there.
So anyway, this works, this is code generating from that SysML model into a working website. You want to go look at LemonTree and the feature branches now?
Sure.
Because what we've got is we've got two models. Those models are basically turned into code by Codebot.
Just to quickly recap the changes. So there was, in this initial model, we didn't have the simulation run domain class, whereas
and you should see the changes very quickly with LemonTree.
You're right, yeah.
It's really exciting for me. I do this every day, many times, and it's very exciting to watch somebody else show it.
So here they are. So that we've got LemonTree version 1, VS Rads, LemonTree version 1, and VS Rads version 2. So I compare. That's fine. That is I think we were saying in the lead up to this, it's actually a good thing it's found some problems in the model itself, which it wants to tell us about. So I'll skip those.
So again, I'm going to repeat my punchline here, which is that as the models get closer and closer to code, you have to version control the models the same way as you version control the code. And Codebot gets the models to be executable code. So so this for me is like really cool. Is that we had a new developer come in. The new developer started working on his own use case to do simulation runs, and now we decide next week we want to back that out or we want to change it or whatever, right? So what I'm looking to do with Parallel Agile is scale my development team by having a new developer come in and attack a new use case. And I want to do that. The more I can have my team work in parallel, the faster my project gets done. And so it's essential to be able to do what you're looking at here. And I'll let Daniel, you talk about the feature branching, you and Matt.
So this is basically best practices we have seen in the industry that if you want to scale your MBSE in a consistent and ISO 2622 compliant way, you have to go into feature branching of the models, because it gives you very good opportunities to review changes, and just like software. And I think this is really the key point Doug made. Once you start deriving stuff from models, they become a valuable asset for your production, and you have to treat them like you would treat code.
Yeah, and so it's worth pointing out the example in this. So like this new class simulation run, so that's the one that gets persisted into the MongoDB database. So it kind of shows down there that also this this aggregation relationship, except that used to point, I think that's actually a brand new relationship. So we know that that's to get all the details. new simulation run class. Also in the
state machine.
In the state machine. So initially we had initial pointing to the first page, the first state, listening for mosquitoes. Then we had this new initial page that became the new sort of landing page, the setup simulation. So in other words, you have to create a simulation first, fill out the form before going to this listening for mosquitoes page. So especially when you're in the early stages of the project, prototyping and doing some UX on the project, and thinking like, I feel like that there ought to be an initial stage in the user flow. So let's have a setup simulation page. It's really easy just to add that in, and then actually just regenerate. And 3 minutes later, you're trying out the new application. It can be web-based. It could be entirely server-based. It could entirely be client-side code. It depends what you set it to generate. And of course, on this, then because you've got multiple developers, multiple teams prototyping all at the same time, at some point, probably fairly quickly, you kind of want to be able to merge everything, sort of continuous integration style, just have everything just kind of merged back in as soon as possible. And this makes it basically painless to do that.
Yes, yeah, and I think it makes perfect sense to use modern version control systems like Git in conjunction with your solution. I have one question to you guys. Your solution, is it more for mock-up verification, or is it meant to be for production source code? If you talk MBSE, I think we have an MBSE focused crowd here today. Is it more for the validation, or is it to create production ready code? For the line of business, I think it's very obvious. It could be pretty production ready. But for the MBSE, what is your take on that?
So sure, go on, sorry.
Yeah, I would say the goal eventually is to be able to produce production ready code. We're still in the fairly early stages with Codebot of doing this. I mean, right now our user interface code generation is released for early access. It's at the moment our database access API is fully released, but the user interface code generation, the state machine code generation is early access only. So we're working towards making it very production ready. But I won't claim that we're 100% on the way there yet. Fair statement, Matt?
Yeah, I think that's pretty fair. Of course, we're looking for
yes,
early access,
which means
volunteers to get involved as well.
The underlying systems need rather rich APIs to call into it. And
yeah, I mean, one of the things that we're working on now is interfacing what's in our model to externally developed code libraries. Right? Okay. So before we get to really, full production ready stuff, we have to be able to link in, third-party libraries and things like that.
Yeah.
That's some of the stuff that Matt's working on right now.
So you have approximately 2 or 3 minutes more for the demo. Do you have one last thing you want to share with the audience?
So one thing I would just add to that is that Codebot is designed because obviously at the start of this, Doug was talking about the parallel agile process and one use case per developer and all that, and the different phases of development we walk through, the proof of concept and so on through to the initial release. So Codebot is designed to sort of just work with you through that process. Is optimized for the process really. So the initial code that it generates is much more freeform, because at that stage there's going to be less detail in the model,
Matt, do you want to show some of the code, like the React code and the Mongo code? We haven't done that yet.
Point actually. I was going to say that, so initially there's no data validation on REST requests and things like that, but then you just kind of switch that on when you're ready. And then you can sort of go from the prototyping to an actual MVP. Then you get really lock the details down at that stage.
So let's just go through like really quickly. This is some of the React.js code that's generated. Codebot generates server-side code for the database, client-side code, client-side API. So you want to look at the server, maybe that simulation run or whatever.
If anyone's wondering about all the red dots, it's just because the project haven't set the project up over here. So, but yeah, so on the server side, but then here, so this is the version 1 of the model. So this is the one without the run simulation thing. But we can see in this it has got, for example, the target API. So this sets up a Node.js or Node Express.js REST API, and it's good to go. It's got a README. It's got Docker setup, and will be set up pretty soon, so you can just deploy it straight into a Kubernetes cluster, for example.
We did make a video out of this example that actually walks through the source code in some detail. It's up on YouTube, so we can provide that link. Matt, can you show like some of the client-side code, especially like the usage sample code?
Sure. Yeah, I'll just quickly point out. So this is a server-side validation that I was talking about. So it uses a JSON schema that it generates as well. So if you want to get quite sort of specific and normative with the code that it generates, then it's that that's all basically there. So it can take whatever detail is in the model for that. So yeah, on the client side, so we've got domain Java domain classes. So I suppose we're looking at target. So I'll just bring that in as an example. It's complaining because I haven't set up the project. So target generates POJOs, basically plain old Java objects. And we've also got JavaScript, TypeScript versions of this, and Swift and C# actually. So various versions of this on the way. Sort of imminently, in fact. So yeah, these these domain classes can be used standalone. If you wanted to, you could just drop them into your own project and use them exactly as they are, or you can use them sort of ready integrated into the generated full stack project.
Okay, I think I take it from here. Thank you, Matt. Thank you, Doc. I think it's really impressive what you built, and why I like it, or why we did this today, is because it shows a ready-made example why you need a clever versioning for models without sharing customer data and stuff like that. So I really like the demo. Thank you very much. So now, because I'm the host, I will tell you a little bit more about LemonTree, and then I will try to wrap it up together with my guests. So one of the main drivers in the MBSE space why people use LemonTree is because they read the standards for safety critical software in a way that they need a strong version control also for the model artifacts. And obviously, why do you need LemonTree? Because you want optimistic version control and not pessimistic. So you need to be able to resolve conflicts with your models. Today, we only showed the diff, but obviously we can also merge. And this was just today to keep the focus a little bit on Codebot. And what you want to do, and I think this is very in sync with the Parallel Agile approach, is that you want branches. You want developers to work on user stories or use cases, as they are called in Parallel Agile, independently and you want to decide which use cases you bring in or don't bring in, and where you see the lemon, is always a good point to sit together and do a review of the solution that has been built. Here is some LemonTree highlights. I don't want to overstress it, but I just want to give you a summary today. I think we showed you today a solution made by Parallel Agile for their method that enables you to create code or an application, including UI, from enterprise architect models. And we also showed you how you will need strong version control or a very good diff and merge tool if you go forward. But this is also applicable to more scenarios, not just to the Codebot scenario. But this was simply a good example what to show you. Matt, do you have something to add?
To that, not especially. Any particular sort of area around it?
Doug, did I miss something in my roundup? In Austria, we use roundup and not lasers.
I think you covered it. I guess, you know, the one point I might want to make is that, you know, one class on that class diagram turns into hundreds of lines of code. I mean, and so being able to version control what you're doing at the model level, it's a big force multiplier. So
yeah, it is worth mentioning about that actually, because one question that does seem to come up fairly often is whether we should actually version control the generated code. So I think the answer is it's entirely down to the preferences of your team and the project and so on. But personally, I would say definitely not, because you only actually need to version control the model itself, and then use that as a. So it's essentially you end up with a UML or a SysML compiler that takes what's in the model and turns it into this complete system, all this generated code.
Yeah, so really the model is the code. Right?
Yeah,
the model
exactly,
is the code, and so what you want to control is the model. And
you execute the documentation.
Certainly one way to think about it. Yeah.
So is there any more questions from the audience? You can use the Q&A pan on the webinar. We have a few minutes left, so feel free to type in questions you might have or comments into the Q&A, and we would be happy to take some questions.
So I would add that if you want to be able to customize any of the generated code or sort of inject particular sort of functions into what's being generated, then that's possible as well. So they can, like for example, you could add an operation onto a class and include some code in that, like for example, on create, which would get included in the REST API. So when an entity is created, just before it's created, then this on create gets called and you can customize what happens there. And of course that all remains in the model again. So it means that you don't have to worry about changing around, you know, the generated code and then thinking, oh, how do I get that back into the model? And so it's all done from source, essentially, from the source model.
So as we have no more questions coming, I would thank you for your attention. And in Europe, I wish you a nice evening. In America, I think it's time to head for lunch. Bye-bye.
Thank you for having us.
Bye.